Dear students, here two cells are connected in series. Here is a cell E1 whose EMF is E1 and internal resistance is R1. So we can show its internal resistance in the series with E1. See, ये R1 है ना, E1 सेल का इंटरनल रेसिस्टेंस, उसे सीरीज में बता सकते. इसी तरह E2 सेल है जिसका EMF E2, उसका इंटरनल रेसिस्टेंस R2 is in series. Means what? Between A and C, E1 cell is present along with its internal resistance. Similarly, between C and B, E2 cell is there along with its internal resistance R2. So that means what? For both the cells, C is a common point. Then these two are said to be in series. That means what? Cells are in series. This we can show in this way also. How? Cell E1 we are showing, below we are writing internal resistance R1. Cell E2 we are showing, below we are writing internal resistance R2 instead of showing in series. So like that also you can show. And big R is external resistance, externally connected resistance. Now current in the circuit is say I, that I is circulating like this. And A is called cell positive, battery positive, and B is called battery negative. So this one or this one or this one, in three ways you can show. Here cell we are showing and here also cell we are showing, but internal resistance we are not showing, but we are mentioning here R1 and R2. R1 is its internal resistance, R2 is its internal resistance. Now next A and C are the terminals of cell E1. See, between A and C, cell E1 is present. So between A and C, this is C, and here also C. So between A and C, cell E1 is present. Then terminal potential difference of E1 means what? Between A and C, potential difference V1 will be equal to E1 minus I into R1. Because when cell is undergoing discharging, then potential difference between its terminals is called terminal potential difference. That is equal to EMF minus current into internal resistance. So V1 is equal to E1 minus I into R1. This is present. V1 means what? It is the potential difference between A and C. Similarly, E2 is present between C and B. So the terminal potential difference V2 will be equal to E2 minus I into R2. And equivalent circuit I have drawn here. Equivalent circuit means what? These two cells combination are reduced into one cell whose EMF is E and the internal resistance is small r. So between A and B. So final points are in A and B. So between A and B, one cell we have drawn here, which I am calling as equivalent cell of that combination. So its EMF is E and internal resistance is R. Now current coming from the circuit is I. So that is why between A and B are the terminals. So between A and B, terminal potential difference, if you write that is V, that is equal to E minus IR. So but here since A, C and B are in series, potential difference between A and C plus potential difference between C and B must be equal to potential difference between A and B. That is why V1 plus V2 must be equal to V. V1 answer E1 minus IR1. In the place of V2, I wrote E2 minus IR2. That is equal to, in the place of V, we wrote E minus IR. So from this, if you write E1 plus E2 minus I into R1 plus R2, this is E minus IR as such. Now, if you compare this, E is equal to E1 plus E2 and R equal to R1 plus R2. And from the equivalent circuit, current E equivalent EMF E by R plus R. So E means what? R1, E1 plus E2. So E1 plus E2 by R plus R means what? Effective internal resistance, which is equal to sum of the two internal resistances. So this is the current expression. Now if there are n cells, one cell whose EMF is E1 and internal resistance R1 is present between A and B. Another cell is present between B and C whose EMF is E2 and internal resistance is R2. Likewise, there are n cells and the nth cell is present till A dash and its internal resistance is Rn and EMF is En. So all n cells are in series. Then this R is externally connected resistance and A is a battery positive and B is battery negative. A dash is battery negative. Then equivalent circuit is this A and A dash. So all the cells are present within A and A dash. That is why A is a battery positive and A dash is battery negative. And all the cells are replaced with one cell which I am calling equivalent cell, and its internal resistance is R equivalent. And this is external resistance and current. Now if you extend that formula, what we got, effective EMF is equal to E1 plus E2 etc. plus En. Effective internal resistance of the all cells is R equivalent, is R1 plus R2 etc. Rn. Now current expression E effective or E equivalent by big R plus R equivalent, this one expression. If cells are identical, each has EMF E and internal resistance small r. Internal resistance small r. Now if this time cells are identical, each has internal resistance small r and EMF E. That is why in the place of E1 E, in the place of E2 also E, in the place of En also E only. So n times. Similarly, that become E equivalent is equal to n into each cell's EMF E. Similarly, R equivalent is equal to R plus 1 plus R n times, because there are n cells but all are having same EMF and same internal resistance. That means what? Equivalent internal resistance is n times of internal resistance of each cell. So then current is equal to E equivalent by R plus R equivalent. That is equal to E equivalent also we got n times of E. So NE by R plus R equivalent we got n times of small r. So NR. In that way I is equal to NE by R plus NR. Now there are 2 points are there. What are those? If big R is very very less than or NR, then I is equal to NE by NR. Big R is ignored here. Then NN got cancelled, E by R. That means what? Current due to combination N cells, this is the current due to N cells, is equal to current due to one cell, that is E by R. Similarly, if R is very much greater than NR, then NR we can ignore. So I is equal to NE by R. NE by R. That means what? Current due to combination is equal to N times of current due to each cell. So this is about series combination.